In this video, we're going to look at the calculations that you do after you've done a titration. In the last video, we did a titration with the idea of trying to work out the concentration of sodium hydroxide solution using a known concentration of hydrochloric acid. We were neutralising them in the titration. Now, to work out that concentration, we now need to do a calculation with the results we got from that titration. So if you're not sure about titrations, do watch that last video. It's about the previous page in the book to this one. But essentially, we had a bottle of sodium hydroxide. That's the alkali of a known concentration. Sodium hydroxide is the alkali. We don't know the concentration of it. And the task was to titrate a known volume of sodium hydroxide. So we pipetted accurately 25 centimetre cubed of that unknown alkali into a conical flask. And then we added from the burette the hydrochloric acid. Now we know the concentration of the hydrochloric acid, 0.5 mole per decimetre cubed. And we stopped at the second indicator changed from pink to colourless. It was phenolphthalein indicator. You are then to use the volume of hydrochloric acid required. So we will read off the burette how much hydrochloric acid we used to neutralise the sodium hydroxide to calculate its concentration. Now, with all calculating quantities calculations, there's 3 steps. Doesn't matter whether it's a solid, a solution, as it is in this case, or a gas. There's 3 steps. First off, we need to calculate the moles of the reactants. We then need to use the reaction equation and the stoichiometry of the reaction equation. So it's moles first, stoichiometry second, and then third step, we need to use the moles equation again to work out the volume of the concentration of the sodium hydroxide in this case. So it's moles, stoichiometry, moles. That's what we're going to do. 3 stages. So the calculation. Okay. First thing we need is the moles equation for solutions. Remember, every calculation, whether it's a solid, that has a different moles equation. So for solids, it's moles equals mass over formula mass. For solutions, it's this one. Absolutely essential you remember this. Let's box it off. If you don't remember this, you cannot do these calculations. Okay, so you have to remember it. All right. So it's volume of the acid from the burette. So it's whatever acid we ran in from the burette. It's the volume that will be in centimetre cubed because that's how the units of volume are on burettes. And we need to turn to decimetre cubed. So we turn centimetre cubed into decimetre cubed. By dividing it by 1,000. So it's the volume in centimetre cubed divided by 1,000. Okay, once we've done that, we multiply that by the concentration of the acid. The concentration of the acid was up here. Let's underline it. So there's always, with these calculations, going to be information in the question. You have to find the information from the question. And then that would tell you the number of moles of hydrochloric acid that we use. And that's step 1, moles. We need to find the moles of hydrochloric acid. So whatever you have had in the burette, and whatever result is in the results table, there's a whole results table here, we'll look at that in a moment. Let's just say we used 28.7 centimetre cubed of acid in that burette. That's what that's telling me. So whatever's in the burette, that's the volume. So 28.7 divided by 1,000, multiplied by 0.5. 0.5 was the concentration. The concentration was in the question. That tells us the moles of hydrochloric acid. So we just plug the numbers into that formula. Learn the formula, put the numbers into it. So that tells us we have that many moles of hydrochloric acid. Now that hydrochloric acid reacted with the sodium hydroxide. Okay, so to figure out how it's reacting, we need to look at the reaction equation. So the NaOH is the sodium hydroxide. Okay, there's no number before that, so there's a 1 there. It reacts with hydrochloric acid. The HCl is the hydrochloric acid. There's no number before that, so there's a 1 there. So this is a 1-to-1 ratio. Okay, 1 mole of sodium hydroxide reacts with 1 mole of hydrochloric acid. Okay, now we don't have 1 mole of hydrochloric acid. We've just calculated we have this many moles of hydrochloric acid. So we have 0.01435 moles. Okay, so if 1 mole of sodium hydroxide reacts with 1 mole of hydrochloric acid, 0.01435 moles of hydrochloric acid is going to react with 0.01435 moles of sodium hydroxide. Now that stage in a 1-to-1 ratio is easy. It's just the same. If it were 2-to-1 or 1-to-2, then that would be different. Okay. Often with harder GCSE questions, the ratio they give you is not 1-to-1. So be wary of that. Easy this time, not always. So we have now found, we've done moles, find hydrochloric acid. We've now done stoichiometry, so that's stage 2. We found in that stage 2 we have 0.01435 moles of sodium hydroxide. So we're going to use this equation again up here. Okay, so it was volume divided by 1,000 multiplied by concentration equals moles. Now, we need to rearrange this in stage 3. Stage 3, we always have to rearrange the moles equation because in stage 2, we've calculated moles. We've just found here 0.01435 equals the volume. Okay, back up to the bit at the top here, the information in the question. We have a bottle of sodium hydroxide unknown concentration, so we're trying to find the concentration. Your task is to titrate a known volume of sodium hydroxide, 25 centimetre cubed. 25 centimetre cubed sodium hydroxide. So back down here, we started with 25 centimetre cubed in a pipette. We need to turn it to decimetre cubed, so we'll divide that by 1,000. And multiply by the concentration. Now we're trying to find the concentration. So that's what we're going to do in stage 3. We're going to rearrange this equation. Okay, now I've done that for you here. Okay, but my view of these things is formula triangles always work a treat. Okay, so we've got this multiplied by the question mark equals the mole. So formula triangles always the same, a formula triangle always the same. Triangle, divide, multiply. Just have to ask yourself, what mathematical sign do we have here? And the answer is multiply. There's the multiply, there's the multiply. So what do we have by the sides of the multiply? We have the question mark, and we have 25 divided by 1,000. 25 divided by 1,000. Okay, so which must therefore mean 0.1435 goes on top. 0.01435 goes on top. Put our finger over the question mark. It's 0.1435 divided by 25 divided by 1,000, and that's going to give us the answer. Okay, and that's what we've done here. So that just explains this stage 3. The answer then is 0.574 mole per decimetre cubed. Okay, we can round that to 0.6 mole per decimetre cubed if you want to. Okay, because we started with 1 decimal place there. So I think that's fine to round it to that, but that answer is absolutely fine as well. Okay, so that's the example in the books, but let's put some proper numbers into it because we've got just enough time in this video to do that. When I did the titration in the last video, this is the data that I got. Okay, so the first thing we need to do is use this data now to work out the volume of acid. This is quite important. So we often do a rough titration to start with. That's where we just slosh the acid in to get a rough idea of where the neutralisation point is. Now I know in that rough titration I went past the neutralisation point, so we can just cross that one out immediately. We're not interested in that at all. Other than, I suppose, what's interesting is I started that one at 0. I actually filled the burette absolutely to the zero line. And so the difference in that titration was 27.4 because we finished on 27.4. It's not necessary to fill a burette to the 0 line. In fact, it's wasting time. Okay, that's why we often have an initial burette reading. This time it was 0.9 I started at, finished at 26.7. So we do need to work out the difference there. It's much quicker to work out the difference than it is to fill the burette to the 0 line exactly, because you can just waste time doing that. So it's 26.7. Take off where I started. I started at 0.9.9. Equals 25.8. So I'm going to write 25.8 in there. Okay, so that's important to do this difference. And it's certainly in exam questions you can be asked to do this. So it's worth going through this stage. 0.4 minus, sorry, 27.4 minus 0.4. I'm not going to use a calculator for that. It's just going to be 27 exactly. 26.4 minus 0.7. That's going to be 25.7. Okay, now the next stage, this is important as well. We have to come up with an average value. So we've done 3 titrations, and this just recognises the fact that this isn't an exact science. Now, to do the average, the first thing as a scientist you need to do is look for anomalies. If there's an anomaly, you get rid of it. Now, you may look at this and think, well, they're all round about 26, 25, 27, 25. Okay, so there's no anomalies. Well, look more closely. Look at the decimals. 25.8, 27, 25.7. Well, these two are very, very close. And actually, with the titration, we would expect results to be about this far apart. Titrations can be extremely accurate. This, therefore, is quite a long way out. 1.2 above that, 1.3 above that. This is anomalous. Therefore, we do not use it in the average. Okay, so to average, if you've got 3 good results, you can add all 3 up, divide by 3. I've got 2 good results, so add those up, divide by 2. So 25.8 plus 25.7 equals, press the equals, very important in averaging to press the equals, divided by 2 equals 25.75. That is our average. That's what's going into the calculation. Do not round at this point. Okay, never round mid-calculation. So 25.75 was our acid. So the next page in your book, you've got your place to work this out in the 3 stages. Remember, with these calculations, okay, 3 stages: moles, stoichiometry. In other words, use the big numbers in the reaction equation. That's the stoichiometry. And the final stage, moles again. So moles equals volume divided by 1,000 multiplied by concentration. Okay, so the volume we've calculated it here, 25.75. So that's 25.75, 25.75. I'm just going to write that on top of that acid there, actually, because I think that's quite. I often think just writing this on top of the acid is really, really useful. Just so it helps you figure out where you're going with the reaction equation. 25.75 multiplied by the concentration. The concentration we used, back to the previous page, that was 0.5 mole per decimeter cubed. In reality, in a lesson, you'll probably use 0.1, but do look. Sorry, that's the concentration of that is going to be 0.5 mole per decimeter cubed. Okay, what we're trying to find out, of course, is the concentration of the sodium hydroxide. And the volume of sodium hydroxide, that's the pipetted number, which we pipette out 25 there. So that's why I write it on top of the equation here. Whatever you've got all the information for, that's what you work out the number of moles of in stage 1. So it's 25.75 divided by 1,000 multiplied by the concentration 0.5. That's going to tell us the number of moles of that. Okay, let's put that all into a calculator. 25.75 is there, divided by 1,000, multiplied by 0.5 equals let's get all that written down there. 0.012875. Never round in the middle of a calculation. Okay, write it all out there. Stoichiometry, it's a 1-to-1 ratio, HCl plus NaOH. There's no big numbers before. Okay, so it's a 1 there and a 1 there. We don't start with 1. We start with 0.012875. So 0.012875 of that is therefore going to react with 0.012875 moles of that, moles NaOH. Remember, if this number here had been 2 and that had been a 1, we'd have had to have halved it. It's not, so we don't, but the numbers here tell us what we have to do with the moles of hydrochloric acid. So that was moles HCl. So hopefully you can see now, we've calculated the moles of HCl there. Okay, in stage 1. In stage 2, we've now looked at the stoichiometry and we've worked out the number of moles of sodium hydroxide. So we now have a volume of sodium hydroxide, we have a moles of sodium hydroxide, so we're going to use this moles equation again to work out the concentration. Moles equals concentration, because that's what we're trying to find out. We're trying to find out the concentration of sodium hydroxide. Moles equals concentration times volume divided by 1,000. Okay, so sticking the numbers in this quickly, we've got 0.012875 moles equals a concentration question mark multiplied by 25 divided by 1,000. It's 25 because that's the pipette. We pipetted out 25. Rearrange this, formula triangle, multiplied, divide, question mark, multiplied. So the question mark goes in the bottom, this 25 divided by 1,000 goes in the bottom. The 0.012875 goes on the top. Finger over the question mark. We're going to divide that by that. So 0.012875 divided by 25 divided by 1,000. Okay, 25 divided by 1,000 equals 0.025. So we're going to do 0.012875 divided by 0.025. That will give us our final answer, which I'm rushing to do before the video runs out. 0.012875 divided by 0.025 equals 0.515. 0.515 mole per decimeter cubed, because that's a concentration, and that's how we do those.